Hey guys, this lesson is from 5.3 from pre-cal. It is called double angle, half angle, and power reducing angle formulas. So there are three main topics here. We're going to go one at a time. We're going to start off with the double angle formulas. So double angle is when you are multiplying the theta on the inside by 2. Now remember, throughout this chapter, our goal is to use the version of the formula that gives us a degree or radian within our unit circle, okay? So that's what's gonna determine which side, the expanded or the condensed version, you're gonna use. We have sine 2 theta equals 2 sine theta cosine theta. Cosine 2 theta is cosine squared minus sine squared, or because of Pythagorean identity, we can rewrite these in terms of only cosine or only sine. I would suggest only using these two when you're verifying and you feel the need to keep only cosines or only sines. If not, you can use this one. And then tangent of 2 theta is 2 times tangent theta minus over 1 minus tangent squared. Be very careful, especially on this one, to follow PEMDAS. So as we look at this first example, we see that the theta being used is pi over 8. I know that pi over 8 is not on my unit circle, and I can visually see that this is the expanded version. So what I'm going to want to do, if theta is pi over 8, I'm going to want to put that theta, pi over 8, on this right side and say tangent of 2 times pi over 8. Because when I multiply 2 times pi over 8, I can reduce 2 pi over 8 to say tangent of pi over 4. And now pi over 4 is a value on my unit circle. On the unit circle, at pi over 4, I have radical 2 over 2, comma, radical 2 over 2. And now that's something I can solve. Remember that tangent is the sine divided by the cosine. And anytime I divide something by itself, it just equals 1. All right. Let's check out the same question happening with degrees, just so you get an idea. 22.5, obviously not on my unit circle. And again, obviously we can see that it is this expanded version. So I'm going to say this is my theta, and I'm going to plug that theta into the condensed side. And I'm going to say tangent of 2 times 22.5 degrees. That gives me tangent of 45 degrees. Now, if you're familiar with your unit circle, hopefully you recognize that 45 degrees is the same thing as pi over 4. So I am using the exact same thing. I'm actually giving you the exact same question, believe it or not. All right. So now let's start combining this concept with something we learned in our last chapter. Okay. They tell me if sine is 3 over 5 and theta lies in quadrant 2, solve these three. Well, the first thing I'm going to do is expand these formulas because I don't know what theta is in order to plug it in here. But I do know that when I expand these, all right, let me come back up here, I'll have a sine of theta, and I do know what a sine of theta is, okay? So let's take this one step at a time. If I expand sine of 2 theta, I have 2 times sine of theta times cosine of theta, okay? Now I'm going to bring down this 2 times, and sine of theta, they told me, equals 3 over 5. Now the only piece of this puzzle that I'm missing is what cosine of theta is. Now hopefully you remember from our last chapter that when they give you one of the trig functions and they tell you what quadrant it is, you can find any of them using the x, y, r properties. So being that they gave us sine of theta is 3 over 5, we remember from chapter 4 that sine of theta is y over r, okay? Which means that my y is 3, my r is 5, and now I have to solve for my x, okay? So these two are given to us. Remember, we're going to use this to now find cosine. So if I know the formula is r equals square root of x squared plus y squared, I'm going to fill in what I know. And now I'm going to start isolating that x. So I'm going to square both sides. Okay. I have 25 equals x squared plus 9. Move that 9 over. When I subtract 9, I get 16 equals x squared. So I have that x equals 4. Okay. So now I'm going to use that to find cosine of theta. And cosine of theta is x over r. Okay. So my x value is 4, and my r value, they had already told me, was 5. Now, I need to remember to use this quadrant rule. Okay. The reason they tell me my quadrant, okay, in quadrant 2, my signs are negative, comma, positive, which means that my cosines are going to be negative, and my sines, which they already gave me, are going to be positive. Okay. So now that I found that cosine is negative 4 over 5, I can plug that in here, and negative 4 over 5. And now I'm just multiplying straight across, okay? So I'm going to call this a 2 over 1 and say 2 times 3 is 6. 6 times a negative 4 is negative 24. And then 1 times 5 times 5, 25. And now I'm done with this first one. Let's move on to the next one. Cosine of 2 theta equals cosine squared of theta minus sine squared of theta. So now that we know what cosine is from the given, what sine is from the given and cosine is from the x, y, and r, we can just plug those in. I also encourage my students to always make that exponent go on the outside of the trig function. So now we can just fill in cosine is negative 4 over 5. And that's what I'm going to square. And then sine is positive 3 over 5. And that's what I'm going to square. So I'm really working over here with 16 over 25 minus 9 over 25, which gives me 7 over 25. Okay, now for this last one, the formula, I'm going to expand it, is, let's go down here, 2 times tangent of theta over 1 minus, and again, I'm going to write the tangent of theta inside the squared, okay? So again, I don't have tangent of theta, but using x, y, and r, I know that tangent of theta is y over x. Y is 3, and x is 4. And then tangent in quadrant 2, when I divide a positive and a negative, sine by cosine, I get a negative. So if I fill this in, I'm going to say 2 times negative 3 over 4 over 1 minus tangent, which is negative 3 over 4 squared. Okay, so to begin with, I'm going to put this 2 over 1 and multiply that numerator, and then on the denominator, I'm going to start to follow PEMDAS and square this fraction. So if I clean out my numerator, 2 times negative 3, I have a negative 6 over 1 times 4 is 4. All of that over negative 3 over 4 squared is going to be a positive 9 over 16, right? This negative disappears in this squared, but this one is still left behind. And then since I'm subtracting fractions, instead of writing 1, I'm going to want a common denominator, so I'm going to say 16 over 16, okay? Now, the next thing that I'm going to do is this big fraction bar right here. Fraction bars mean division. So I'm going to say negative 6 over 4 divided by, instead of the big fraction bar, and then now I'm going to clean that denominator. 16 minus 9, we have 7 over 16. Okay, so again, that fraction bar became a division sign. Now at this step, I could do keep, change, flip. I'm going to multiply by the reciprocal. And now remember that at any point that you have fractions and you are in the multiplication step, you can reduce. So I'm going to reduce that 4 and 16. 4 divided by 4 is 1. 16 divided by 4 is 4. You could do the reducing after, of course. It's just I like working with smaller numbers. So I have negative 6 times 4 is negative 24 over 1 times 7 is 7. And we are done with this problem. All right, so now we're going to combine what we learned from 5.1 all the way up to 5.3 so far. Okay, so this is a question that says to verify, and then we have sine of 4x, and we want to prove that that is equal to this right side. So in the past, I've told you to start with a more complicated side, but if you can recognize that here I can start working with double angles and things like that, then I want to start working with this simpler side. So for starters, from 5.2, I can recognize that I can split that sine of 4x into sine of 2x plus 2x, right? And now I have a sum and difference formula from 5.2. So the formula says that sine of the first times cosine of the second plus cosine of the first times sine of the second. Okay, and again, that is from 5.2. Now, if you notice, now that I split it using that formula, I have 4 different double angles. And the way that I know that I want to use the double angle formula is because if I look at this right side, all of my x's have a coefficient of 1, and these still have a coefficient of 2. And by using the double angle, I can get rid of that. So let's do one at a time. Sine of 2x is going to give me 2 sine x cosine x. Okay, that's the first one. Now times cosine of 2x. So in the formula it said theta. It's just a variable. It's cosine squared of x minus sine squared of x. Okay, so that's my second one. Now I'm going to write the plus sign. Cosine of 2x is the same one we just wrote. So cosine squared minus sine squared. And then the last one, sine 2x is 2 sine x cosine x. Okay? Now, for this next step, let me just keep writing notes here. So when you go back, you know what you did. Here we used double angle formulas. Okay? Now, since the double angles for cosine have 2 terms, in order to complete this multiplication, I'm going to have to distribute these into both of these terms. Okay? So I'm going to have to get all of this and multiply it to a cosine squared, and then minus to a sine squared. And then I'm going to do the same exact thing on this right side. Okay? So all of this times a cosine squared is just going to make the cosine be a cubed. 2 sine x, and then there's 1 cosine here and 2 here, so cosine cubed minus, now when I multiply all of this by a sine squared, it's just going to change the sign to be cubed. 2 sine cubed cosine x. Bring down this plus sign. And now the same exact thing is going to happen here. All of this times a cosine squared is just going to make this cosine be cubed. So 2 sine x cosine cubed minus all of this times the sine squared is just going to make that sine be cubed. All right. So now again, I have 4 different terms. I've got 1, 2, 3, and 4. This is starting to look favorable. If you look over here, notice that I have a sine cubed and a cosine to the first, and a cosine cubed and a sine to the first. Okay, so this is starting to look right. Now what I'm going to want to do is combine like terms. I've got this term with a sine to the first and a cosine cubed, and this term with a sine to the first and a cosine cubed. That's me combining like terms. So there's 2 here and 2 here, which makes a total of a positive 4 sine to the first times cosine cubed. And then I have negative 2 sine cubed cosine to the first, and another one with a sine cubed and cosine to the first. Negative 2 and negative 2 make a negative 4. And hopefully you keep eyeballing that right side of this verify equation, and you can see that we did it. It is identical to what I wanted to match up. I can stop now. All right, let's try one more of these. All right, so same concept. I have a cosine of 3x. I'm going to split that to cosine of 2x plus 1x, right? 2x and 1x make 3x. I want to try and make it look like this. Notice that on this right side, I only have cosines, okay? So let's start off with that same step we took last time. I'm going to use the sum and difference from 5.2. Cosine of 2 things being added. I have cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay? Notice that this one and this one I can change using double angle. Okay? The cosine to the first and sine to the first I'm going to want to leave for now. So cosine of 2x, I know last time I showed you cosine squared minus sine squared, but remember I want everything in terms of cosine. So I'm going to use the formula that read 2 cosine squared of x minus 1. Okay? And then I'm going to drop down this times cosine of x minus sine of 2x. Well, I only have one option there, which is 2 sine x cosine x. And then I'm going to bring down this times sine. Okay? Now, notice here that because there are 2 terms, I'm going to have to distribute this cosine. And then here, when I multiply this sine, it's just going to change the exponent of that sine. All right? So cosine times this cosine is just going to make it cubed. Minus cosine times 1 is just cosine. And then minus 2, this is going to become a sine squared times cosine of x. Okay? So far, I only have one sine left. Everything else is already a cosine. Let me take you back. We went over this in 5.1. This sine squared, using Pythagorean, right? Pythagorean says sine squared plus cosine squared equals 1. Well, if I move this cosine over, I can isolate that sine squared. All right, I'm just subtracting the cosine squared over. And now I can rewrite this sine squared as 1 minus cosine squared. Okay, so I'm just going to rewrite this part. This is a rewrite. This is a rewrite. The minus 2 is a rewrite, and now the sine is going to become, I'm going to put it in parentheses because there's 2 terms, 1 minus cosine squared x, and then I need to rewrite this last cosine. Okay, so that sine squared became 1 minus cosine squared. Now, all I have left, I'm going to distribute this 2 first. Okay. Actually, I'm going to distribute a negative 2. So negative 2, and then a negative make plus cosine squared of x. But these two terms still needed to be multiplied by a cosine of x here. So now I'm going to distribute that cosine. So I'm going to have, oops, I forgot my cubed up here. Here's a rewrite. Now minus 2 times cosine plus cosine cubed. So I got to look at my top. I should only have two terms. One term that has a cosine cubed, which I can catch that I've got one here and another one here to combine. Okay. Oh, and I totally forgot to distribute the 2 right here. Look at that. So this should have a 2 in front of it. Okay, so 2 and 2 make 4. The way that I caught my mistake is because I saw that this should have a coefficient of 4. So I went back to see why doesn't this equal up to 4, and then I caught that I forgot to distribute the 2 right here. So now I have 4 cosine cubed. And then I noticed that I need negative 3 cosine to the first. Well, here I have negative 1 cosine to the first and negative 2 cosine to the first. And now we have exactly what this says.